This question is from year 2022 Mechanical Engineering paper set 2, question number 62. A uniform wooden rod, specific gravity being 0.6, diameter being 4 cm and length 8 meter, is immersed in the water and is hinged without friction at point A. This is point A as shown in the figure. A solid spherical ball made up of lead with specific gravity 11.4 is attached to the free end of the rod to keep the assembly in static equilibrium inside the water. For simplicity, assume that the radius of ball is much smaller than the length of the rod. Assume density of water as 10 to the power 3 kg per meter cube and pi as 3.14. Radius of the ball is dash centimeter, rounded off to 2 decimal places. Let's find it out. Now, as we know, this is a question based on the concept of buoyancy. Point A is given to be a hinge point without any friction. There is no restraint to rotation at point A, and therefore we can use the equilibrium equation. Summation of moment about point A is 0 because there is no net resisting moment at point A. Now let's say weight of the rod is going to act at CG. So let this be WR, weight of the rod, this be WB, weight of the ball, and FR and FB be the buoyancy forces on the rod and the ball. Then we can write bending moment about point A as anticlockwise taken positive. So FR into this distance here is X and this one will be 2X. This one will also be X because weight acts as center of the rod. And therefore we can write FR into X. This is the anticlockwise moment plus FB into 2X. This is also anticlockwise. Then we have WR and WB creating a clockwise moment. So minus WR into X minus WB into 2X is equal to 0. Taking X common, we have FR plus 2 times FB minus WR minus 2 times WB equal to 0. Now we need to substitute each of these values. So buoyancy forces FR and FB can be written as FR, buoyancy force on the rod, will be equal to weight density of liquid, which can be written as density of liquid rho L into G into the submerged volume. So submerged volume of rod will be the complete volume because complete rod is being submerged. So we have pi by 4 into capital D square into L. Capital D is the diameter of the rod and capital L is length of the rod. Then we have FB for the ball will be equal to rho L into G into volume of ball will be 4 by 3 pi D cube by 8. So here small d we have taken as the diameter of the ball. So T cube by 8. We need to find out small d itself. We can also write weights for the rod and the ball. So weight of the rod will be equal to density of the rod into G into again its volume. So pi by 4 D square L, and WB for the ball will be equal to rho B into G into 4 by 3 pi D cube by 8. So let's substitute these values here in the equation that we got from moment equilibrium. So we have rho L into G into pi by 4 D square L plus 2 times rho L into G into 4 by 3 pi D cube by 8 minus rho R into G into pi by 4 D square L again minus 2 times rho B into G into 4 by 3 pi D cube by 8 is equal to 0. Now we can see G and pi are common in all the terms. So we can divide the whole equation on both sides with G and pi. Also, when we divide with rho L, each of the term, we will get this will be D square L by 4 because pi is already divided, G is already divided, and this is 1. So the term left is D square L by 4 plus 2 times 4 by 3 into D cube by 8 minus rho R by rho L will be the specific gravity of rod. So we can write it as SR into D square L by 4 minus 2 times, again this will be specific gravity for the ball material. So SB into 4 by 3 into D cube by 8 is equal to 0. So for now we'll keep D, L and small d as it is, and then we can substitute D and L finally. Now we'll substitute the values of SR and SB and also simplify the coefficient values here. So we'll have first term as D square L by 4 plus the second term becomes 2 into 4 is 8, 8 by 8 is 1, So we are left with d cube by 3. This will be equal to, we take these terms to the right hand side. So we have SR is given to be 0.6. So 0.6 d square L by 4 plus 2 into 4 is 8, 8 by 8 is 1. So we have SB 11.4 into d cube by 3 left here. Now taking all the terms containing small d cube on one side, we will have 11.4 times d cube by 3 minus d cube by 3 will be equal to d square L by 4 minus 0.6 times d square L by 4. Taking the subtraction, we have 11.4 minus 1, which is 10.4 d cube by 3 will be equal to 1 minus 0.6, which is 0.4 d square L by 4. Keeping d cube on one side and taking all other terms on the other side, we'll have 0.4 upon 4 be 0.1 into d square L into 3 will give us 0.3 into d square L upon 10.4. Substituting the value of capital D and capital L, capital D is 4 centimeter and capital L is 8 meter. So we'll substitute all values in centimeter because we need D value also in centimeter. So we'll have 0.3 into 4 square into L will be 800 centimeter divided by 10.4. This gives us the value of D cube as 369.195. And taking cube root on both sides will give us the value of D. So D turns out to be, cube root of 369.195 is 7.17 centimeter. And we are being asked the radius value. So just dividing both sides with 2, we will have the radius as 3.587 centimeter, or rounding it off to 2 decimal place, we have 3.59 centimeter. Let's go back and fill in this answer. So radius of the ball is 3.59 centimeter. To learn more about buoyancy concepts, you can refer to the NPTEL video, Module 4, Lecture 4, Fluid Statics, Part 1. It is from the course Fluid Mechanics. The course is taught by Professor S.K. Som. He is from Department of Mechanical Engineering of IIT Kharagpur. I hope this solution helps you clear your doubt. Thank you.